So this session is titled Introduction to Large Language Models. We're looking at about an hour presentation here, and the focus is really to obviously introduce you to large language model and generative AI as a topic. I'm sure many of you have had some experiences already, probably most of you with something like ChatGPT, and have some limited experience with AI and with ChatGPT. And so what we hope to do in this presentation is inform you, educate you, give you a bit more information on the concept in general, and then talk a little bit about where the technology is going with some examples of actually some real world technology and how that is integrated and how that might help you in your use of AI in terms of improving your efficiencies when you work. So my name is Kurt Rolland, and here's my business card slide, if you will. I'm a principal architect with Covenant Technology Partners. I have many decades of technology experience, both in the corporate world as well as ISV, software development, and professional consulting. So there's my contact information on LinkedIn. Please like, connect, or follow me. I do blog, I write articles and posts and so forth, so I'd love to keep in contact with y'all. Additionally, we have a LinkedIn public group that's focused specifically on Microsoft 365, artificial intelligence, content, and collaboration. It is a public group on LinkedIn, and would love to encourage you to join that group. We do posting within that group and allow you to collaborate with other folks with similar interests. So our agenda for today, again, we're looking at about an hour or so, but what we'd like to cover here is a brief introduction to artificial intelligence. And the real question here is we'll talk a little bit about what AI is, but perhaps the more important question is, how do we get here? How did we get here so fast? It seemed like, AI's kind of been out there. It's been talked about, in the news and maybe even within technology circles or maybe at work. But it's been a little bit of an elusive kind of concept, or maybe it's been very, very specific in terms of its use, maybe around some forecasting or predictive analytics or something like this, but it's been fairly narrow kind of, right, when it comes to the corporate world. So now what's changed? All of a sudden there's this huge explosion that's happened in about 6 or 8 months. Amazing, right? So what happened? Then we'll get into defining some terms. Some of these you may be familiar with. Hopefully we can kind of drill in and get a little bit more precise on what we're talking about. We'll talk about what is Gen AI specifically and how is that compared to AI in general. We'll talk about large language models, small language models, and GPTs. Kind of what's the difference between all these things, and why would I use one over the other? We'll then get into, I call this prompting for prompts, because prompt engineering, if you're somewhat familiar with it, is kind of becoming a new necessary skill. And I'll just say that while I think there's a lot of perhaps fear, uncertainty, and doubt about what AI is going to do to your particular job and your particular job function, right? What we're seeing is that while AI may not offset you or replace you in your job function, someone who knows AI or knows how to work AI may replace you. So the idea is it may not be AI specifically that pushes you out, so to speak, or maybe replaces your job role, but you really need to know about AI, specifically about how it improves your job function and how it makes you more productive. That makes sense. And then finally, we're going to do a kind of cursory overview of a very specific Gen AI example. I'm going to focus on Microsoft Copilot because I work for a Microsoft partner, and so we do a lot of work with Microsoft Copilot. For you all, if you're not using Copilot, think of ChatGPT in terms of what I'm going to be talking about. I'll maybe be doing some comparing and contrasting of what you may be familiar with ChatGPT and how that relates to Copilot. Make sense? Okay, great. And actually, I'm going to go to the next slide here, and I'm just going to say, to the point of what happened, note that the following I'm going to show you was not publicly available just 6 months ago. That's how fast the technology is moving. Okay, so I'm just going to show you a quick demo. It's actually a video. Okay, so you may be saying to yourself, well, hey, I've been using ChatGPT for a year and a half, and I've been able to generate stuff. So what's different about what I showed you though? See, you're using ChatGPT, you're pretty much tied to that chatbot kind of interface. Can you generate information? Absolutely. Can you generate text results? Absolutely. Even with something like DALL-E, can I generate images? Absolutely, right? I think the big difference, though, in what we're seeing here is the integration of generative AI, specifically bringing them into contact with day-to-day work tools. You see the difference? So, for many of us, we're using the Office product suite, right? We're spending most of our day in Teams and in Word and in Excel and so on and so forth, right? So now what you're seeing is the tighter integration, let's say, of generative AI and prompting right built within the products, okay? So the acceleration you're going to see is kind of more moving from a kind of a generic GPT kind of model, ChatGPT kind of model, which I'm not taking anything away from. It's a great model, right? But the idea of more tightly integrating the generative AI prompting specifically to products. So what I showed you was integration with the Office suite, with Copilot. That's a lot of what Copilot does, right? What you're going to begin to see is you're going to begin to see this kind of integration in more and more proprietary products, vertical products, industry-specific products, and so forth. So I'll take examples: Salesforce, project management tools, these kinds of things, right? You'll begin to see the Gen AI coming into those tools, and you'll begin to see assistance capabilities built within the tools. Make sense? Okay, great. So let's then talk about an introduction to artificial intelligence and kind of how is it we got here, right? So obviously the world's changing, no doubt about that. Things keep changing. Industries are transforming. The ideas of generating higher and higher economic growth continue to be pushed. And the technology, specifically around AI, is at this inflection point, right? Which is, okay, how do we take something out of the lab, okay, or that's been used for very, very specific point type solutions, right, and bring it into, I'll use the word way of working. So when I say a way of working, what I'm talking about is what you do kind of moment by moment, hour by hour to produce work products, right? Your work products. In your job role or your job function, what is it that you need to do every day? Well, I need to, write reports. I need to analyze spreadsheets. I need to, communicate via email. I need to be on some Teams meetings, so on and so forth, right? So how does this transform that kind of activity? So when we look at a brief history of AI, we see that, again, AI is not a new thing. It's a relatively new thing, but not incredibly new. So we go back to the 1950s. This is really kind of where the start of AI is sort of measured. That's a measuring point, right? This is definitely labs and white coats. This is sort of, the IBM in the lab. We're trying to do some interesting things with some servers. They're not talking about a lot of data here, right? The focus is more on algorithms. How do we program algorithms to achieve something like a human intelligence? But data sets were small. Computing power was what? Low. Although it's still amazing to me that we went to the moon with the technology that we had, which was mostly analog, right? And yet today we can't seem to get to the moon with artificial intelligence. I mean, is that really weird or what? Another topic. So again, you can see that artificial intelligence here started in the 50s, and then in the late 50s we began to move into machine learning, where we're actually trying to learn from existing data. So rather than just being purely algorithmic, let's write some algorithms that can do some stuff. Actually, does anybody remember fractals? So what were fractals? Anybody? You remember what fractals are?
I can't think of the definition.
Yeah. So fractals are basically it's algorithmic based image generation, right? So the idea was that you weren't generating images based on data, or should I say raster images, right? Like dots. What was happening was that a vector image was being generated by an algorithm. Okay. Now, the difference is that algorithm was not based on some natural language input. You see what I'm saying? Okay. So we can see the beginnings of the kind of evolution of this thing, right? The focus initially was on the algorithms. How do we produce interesting endpoints using algorithms? And then as we move into the 2017 here with the deep learning and the neural networks and so forth, now we're beginning to bring together the algorithms or the rationalization, okay, with the high element of data processing in the large language models. Okay, so the point here is it's been an evolutionary process. It's taken multiple decades, okay, but, and you'll see on this next slide, with generative AI, what has happened here is that a number of things have converged to actually make things what they are in a very, very relatively short period of time. I mean, a few years, essentially, right? So what has happened? If we look here, everyone knows what Moore's law is, right? So we apply a Moore's law kind of idea to acceleration and expansion. We're looking at a number of convergent things that came together that really make AI viable in the state that it's in, right? So we have the human-like levels of performance and accuracy in multiple computer disciplines. So that kind of goes back to the algorithmic thing we've been talking about, right? We have improvements in natural language processing. So natural language processing is this idea of computer systems to be able to interpret that human language, if you were the human language element, into intent, right? And it's not just simply breaking down grammar and words into sentences. It's more than that, right? The expanding computer processing power performance. We couldn't be doing what we're doing today unless computers continue to get faster and faster and faster. And then finally, this is a big one, massive amounts of data available from the World Wide Web. Why is that needed? Why is that important? Well, because the large language models have to be trained on literally billions and billions of amounts of data. Where's it going to get it? Well, guess what? The World Wide Web. So the underlying point here is data is the new gold, right? Data was used to get us to a point of developing the large language models, right? And for you and your organizations, data is your gold as well, because ultimately you're going to be utilizing your own data sets and AI, coupling those things to achieve better and more efficient results. So Gen AI cannot be Gen AI without data, without lots and lots of high quality data, right? So we were just talking, Pete and I were just talking about Fabric, for example, or Snowflake, So what this is doing is this is causing organizations to begin to get their data governance and data classification and sort of things in order, right? Because unless you have these things in order, you're not going to be able to generate good results using Gen AI. This is kind of another slide that's related to the one I showed previously with regards to convergence. This is really more about adoption rates, okay? So what this is a really interesting graph, because what it's showing is the amount of time it took to reach 100 million users. So the slide assumes that if you can reach 100 million users, you've gone from kind of an interesting technology to some level of adoption that really becomes a wave or an impact, right? So if we look at the smartphone here, it took 16 years for the smartphone to achieve 100 million users. The internet, 7 years. Instagram and TikTok, social media platforms, a lot less, right? We're moving into months. ChatGPT took 2 months. Do we see a trend here? So why is this happening? Well, I would argue part of it is that everybody's networked. Everyone's, integrated somehow, right? And so the rapidity with which these new technologies get communicated and adopted are just simply much faster, right? We're communicating at speeds that weren't achieved before. But I think the other thing too speaks to the level of transformation that can occur with generative AI. Okay, we were just talking earlier, a few of us, about well, geez, some of this is coming from corporate boards. Our corporate boards are saying, hey, you know what? We're doing AI. We're doing Gen AI. You guys need to figure it out. But what we're telling the market, what we're telling customers and so forth, is we're an AI company, right? Now, they may not know what that means, but it carries a lot of weight these days, because if you're not doing anything with AI, at least you're not publicly communicating that you are, right? You're considered perhaps behind the times, right? This is just an impact slide, just showing the impact of AI as it relates to total GDP, global GDP, right? So, the message that this slide intends to show is that the impact on global GDP is expected to increase at higher and higher accelerated rates using AI technology, okay? And so you can see here, this goes way back, right? Industrial revolution, steam engines, okay? What was the impact on global GDP with the introduction of steam engines? So we're looking at the Industrial Revolution here, and how the curve or the impact on global GDP has gone up, okay? We got the PC introduction here, we got the internet, smartphones, the cloud, and the point here is that AI, or generative AI, is going to continue that upward curve and that upward push, right? Again, what's the underlying assumption? That technology improvements drive GDP growth at faster and higher rates. You all probably heard of the hype cycle, the Gartner hype cycle. Okay, so here's an interesting one, right? So this is in 2023, okay, fair enough. But notice where generative AI is here in the hype cycle. It's at the very, very top of, I'll just read this, the peak of inflated expectations. Okay, so what that means is that everybody's excited about it. Everybody feels like they need to do something or say something about Gen AI, right? However, note that we're just getting ready to enter the what? The trough of disillusionment. What does that mean? Go ahead.
I'm just, I wasn't trying to answer. I was just going to ask, how old is this chart?
2023.
2020. Oh, I didn't see it.
Just last year. Yeah.
Yeah. I got to feel we got a little bit more hype to go. We're there.
Perhaps. But I guess all that means to say is that, maybe we're here on the curve, right? Yeah. As opposed to here. The point though is regardless of kind of where we're at, whether it's, we still got a bit of an upward to go, right? What we will find at some point is translating the hype into reality. When I say reality, I'll go back to the way of working. How does it impact you productively in your day-to-day tasks, right? We're beginning to see people start to work with the technologies, and we're seeing some people go, hey, this is great. This is really making an impact for me. And others are like, yeah, it's not quite as good as I thought. Well, if we were to guess where that rubber is hitting the road with regards to the crop of disillusionment as it relates to Gen AI, does anyone have a sense for what area that may lie, where they may begin to be disillusioned?
Results.
Prompting. That's right. Prompt results. See? Hey, I expect to put in 3 words and it's going to write, a 100-page, report for me. That's probably not possible. Or it may be possible, but it's not going to give you what you really want, right? So,
Give you something.
so why do people have that expectation?
They may start to have to pay for it.
Well, okay, there may be that, but I guess I would argue that what's happened to communication between humans? Has it gotten longer or shorter? Yeah, I mean, if you look at X, right? I mean, hey, I want to say as little as possible, but say as much as possible with as little amount of words, in a sense, right? The challenge, of course, with prompting, and we'll talk a little bit about this, right, in more detail, is that with prompting, you've got to be more long form in terms of telling it what it is you want. Okay, because while it mimics human intelligence, it's not a human. Okay, all right.
What happens when most of us start writing, when most writing is no longer done by humans, right? Like for the your slide, the disillusionment.
Yeah.
Right. Like if most of the emails are written by AI and then read by an AI, or nobody's actually writing on Stack Overflow anymore, which is already happening. What's that going to do for all the investment we've made?
Well, that's a great question. My prognosis is that AI will never replace humans. There's this principle of what's called human in the middle, and actually we talk a bit more about prompting and prompting results. Responsible AI principles kind of dictate that there is some kind of a human review of what the Gen AI produces, right? We're just simply not to the point where responsibly we can just sort of let that response go through, because there could be hallucinations, there could be inaccuracies and all those kinds of things based on my prompt, the data that was used to train the large language model, and the large language model itself. Okay, now, will there be a point where the large language models, the prompting, I mean, everything is basically kind of taken over by computers? That feels like a very dystopian idea. I hope not. But at least today, human in the middle is pretty much required. Unless you're dealing with a highly automated AI-based process, like some kind of predictive analytics or something like that, right? There you let the models run, the models are going to produce something, but maybe even at the end, the model production of the output needs to be reviewed by somebody, or at least assessed by somebody for accuracy. Okay, so we're going to turn the corner now and talk about large language models and what they are, okay? So again, we're just going to go through some definitions. What is artificial intelligence? There's a bit of a description there, but the idea is it's really not just one technique. It's a kind of a broad set of techniques that are used to what? The operative terms are to train computers. So generally speaking, we talk about artificial intelligence, you've got the idea of a model. We're not even talking about large language model. We're just talking about a model, okay? So the model is a kind of a projection of reality in a sense, right? What you're trying to do is you're trying to indicate through the model what you want the computer to do. And then there's this idea of training, because you need to tell, like a child, you need to tell the model or the computer with the model, what your desired results are, because it doesn't know. All right. So once you've successfully trained the model, now you need to give the model both positive and what? negative, right? Because it needs to know parametrically what is considered expected, right, in terms of output, right? So you give it positives and negatives, and then from there, you're hopefully at a point where you can actually, use the model. Now, garbage in, garbage out, right? So the effectiveness of model is going to be based on the quality of the data going in, as well as the amount of data going in, right? The more data you can give it, and the better quality data, potentially the better quality of results. Now, this is true whether we're talking about large language models or a object detection model. That's not language based, right? An object detection model is simply using video or imaging to detect a particular object that may appear right in that field of vision. Okay. So we're talking about more generalized AI concepts here. Okay. Now we talk about generative AI specifically. What we're talking about, and again, the operative words here are creating original content that doesn't already exist. Now it's going to create new content based on something else, some kind of a derivative. But, Gen AI, again, kind of assumes that you're creating something new, something that didn't exist before. So what's a Gen AI model? So we take the idea of AI principles, the idea of training a model, okay, as well as creating new stuff, as opposed to just merely analyzing something like object detection. We're creating new stuff, okay? So as you can see here, we're dealing with an algorithm plus the data, okay? So really, in order to come up with an effective model, you need the algorithm, the rationalization, and then you need the kind of the data points that you're using to train the algorithm, okay? It is just a mathematical reproduction, if you will, of a real world idea, right? It's an abstraction, basically. We talked about the idea of feeding large amounts of data to train it, allow it to understand the good and the bad, the positive and the negative. And then assuming that we train it properly, it can produce new and never before seen data and make predictions or analyze patterns. So in general, that's what we're talking about. Notice here too, that as we talked about the history of AI, we can see that we started out here with machine learning, which we kind of talked about from the 50s, right? And then from there, we developed neural networks, and now we're at the point of using generative AI models. So why should I be interested in Gen AI? What can it really do for me? Okay. So the nice thing here is that there are really three basic areas, and I'm sure we're not limited to three. I'm just trying to kind of summarize this for you, right? But there's automation, there's assistance, and there's augmentation in terms of what AI can help us with. And if we look at the graph here, we see that we've got the machine over to the far left, and we've got the human at the far right. So what we're talking about here is the proportion of involvement in these kinds of tasks, okay? We also see low complexity and high complexity on our y-axis here, okay? So if we take low complexity or relatively low complexity and something that's much more oriented towards a machine, let's say, meaning there's less human involvement, we're really talking about things like, automation, report generation, those kinds of things, right? These are things that, while a human may be involved, they don't need to be highly involved, right? We're going to let the process kind of develop those things. In this middle area here, we talk about assistance. So this is really the kind of way of working area. So here we're using what the machine can do, the best of what the machine can do with the best of what the human can do. But the human still needs to be involved in evaluating that output, okay? At the far right here, we see augmentation. So augmentation is really mostly about the human doing the work. But what the machine's doing is it's giving you starting points, so to speak. So the classic example here might be, I don't want to sit and look at a blank screen. I've got to write a report or do something, right? Rather than looking at a blank screen, right? I may have Gen AI start me with something, right? But I'm really mostly doing the work. I'm kind of using it as a way of providing some raw material for me, right, in my creative process. but I'm ultimately going to do most of that stuff, right? So if we're doing real strategic kinds of things, right, it's probably going to be mostly human. Okay, so what are large language models then? So with large language models, what we're doing now is we're taking specifically text data here, and we're taking that and we're training the model itself. I think it's interesting to note here that when we're talking about ChatGPT and the large language models, the OpenAI language models here, we're talking about hundreds of billions of parameters. Okay, so this is not something you're going to do on the weekend. And you may ask, well, gee, when did all this happen? A number of years ago, I'm sure, right? So the OpenAI folks were doing this stuff in a lab, and we didn't even kind of know what was going on, right? They were training and building the large language models, and all of a sudden it's like giving birth. Oh, well, there it is, you know. Well, they've actually been doing it for years, you know. They've been tweaking it, they've been refining it, and so on and so forth. Okay. These are obviously extremely expensive to build because of the computing power, the time involved, the human interaction involved, and all those kinds of things. Okay. All right, now we've got this other thing called a small language model. Right, well, what is that? Right? So take the idea of a large language model, and rather than being relatively broad and say relatively shallow in terms of its prompt understanding, it's, in other words, pretty generic, right? What we're going to do is we're going to narrow that, and we're going to go narrow and deep. Okay. So why would I want to do that? Well, so if you have a large language model, you may have to spend a significant amount of time in your prompting to get the kind of results that you want, because it is pretty broad and pretty generic, right? Can encompass lots and lots of stuff, right? Everything from, you know, writing English composition paper on, you know, Blaise Pascal to, you know, developing a SWOT analysis for a project. I mean, it's kind of pretty all over the board, right? However, if you have a small language model, your prompting can be less accurate. Is probably not the right word, but it could possibly be less involved. And the reason for that is because you're dealing with a smaller and narrower data set. So let's use an example. Let's say pharmaceuticals. Let's say you want to develop a small language model that can give you information on drugs, drug names, how can I say, interactions or results of taking drugs, you know, whatever, right? Well, you can develop a small language model on that and then use prompting to ask it questions. Now, the prompting you're going to ask that is going to be much, much more specific to pharmaceuticals, right? You're not going to ask that small language model to write a paper on Blaise Pascal, although you might. I could. I could ask it. That's right.
Yeah. Kurt, is that, yeah, so one of the themes that we have, so we're a nonprofit, and one of our we want to use AI, right? As everyone does.
Yeah.
And one of the thoughts is our grant writers, could we ingest all of our statistics and data and say, a grant writer can say, oh, I need to know you served from this time period, right?
Yep.
Theoretically, it's all there. And I'm assuming that's probably even smaller than a small language model, right?
Yeah. So we'll get there. We'll get there.
Okay.
Yeah. We'll talk about that, because again, I like to call it three legs of the stool. When we talk about generative AI, there's three legs of the stool. Okay. One is the large language model, the type and quality of the large language model. Okay. The other is the prompt, the quality, the completeness of the prompt. The third is additional data or context that I bring into the equation. Okay. And we'll get there. We haven't talked about that yet. That's context. Yes.
Can I ask about small language models? Having never used one, heard it before, but never used one. Familiar with ChatGPT and being able to just type whatever I want. I know that it's been built on, hundreds of millions of pages and billions of parameters that you're saying,
Mm-hmm.
and that it lets it infer all of the grammar, the text, the attention that it needs to bring everything out so it can talk to me in English. I wonder if I'm using a small language model and it doesn't have that large corpus behind it, is it still a text interface, or does it become more like SQL practically because it just doesn't have as much grammar knowledge?
Sure. Great question. So it depends on how the large language model is written, because remember, there's a rationalization piece And then there's a data piece that's used to train the algorithm or the
Wait,
rationalization.
so you said large language model there. Do you mean small
Well,
language model?
whether it's large or small.
Yeah.
I mean, both conceptually do the same thing. The only difference between the two is the amount of data that you're putting in it and the rationalization or algorithm, right?
Mhm.
Is your algorithm broad or is it narrow, right?
Mhm.
Is the amount of data that you're feeding it broad or is it narrow?
Mhm.
See? There's also the issues of speed. And I think I have a slide to talk about this, but the idea is that the smaller the language model, okay, the smaller the amount or the size of the model, as well as the faster, right, the prompt can be processed, okay, which means that it may adapt itself or lend itself to portability. So let's say, for example, that you wanted to have a small language model on your mobile device, right? Because you're not always connected to the internet, for example. You want to be able to consult it here for a very specialized kind of application. That's where a small language model might really, really shine. Okay, small, it's fast, right? Goes on my mobile device. Don't need to be connected to the internet.
Mhm.
Okay. All right. So as we talked, with a large language model, we are talking about hundreds of billions, whereas a small language model, we're probably talking about hundreds of millions of data, amounts of data being fed in to train the model. Okay. And as we mentioned, the World Wide Web was really the primary source of training many of the large language models that we know today. So we've talked somewhat about OpenAI, but it's important to note that I would say any top technology vendor has an iron in this fire. Okay. So, with Microsoft and with Copilot, they're affiliated with OpenAI here, right? But we've got Meta, Facebook, we've got Gemini, we've got Claude. I mean, I would expect every few months there's going to be somebody else introducing, if not their own large language model, more and more variations of language models that are either more specialized or faster, right? So note that it's not a single size fits all, nor is it a single vendor kind of competitive landscape. So your choices are pretty open here, as well as we were talking about SaaSes are beginning to be developed now, software as a service. So rather than you having to worry about combining a large language model with something that you're trying to do, hey, you just simply subscribe to a SaaS service that has a language model or a GPT kind of an interface. Again, I'll use the pharmaceutical example that may give you very, very specific, information or insight into that specific discipline or area. Okay, it's just going to be more and more expansive, I think, in terms of where this is going. We're really, really just at that inflection point.
Kurt, one thing to bring up, so since you brought up pharmaceuticals, pharmaceuticals are very tightly controlled in terms of what they have for their intellectual property, right? So it's going to be very difficult to use a large language model and be able to go after what they're doing because of all the protected data that they have. So therefore, they'll probably be doing a lot more training on their own data to be able to be that much more specific on what they're trying to achieve, because everything else on the outside may not be particularly, or maybe skewed away from what they're actually trying to get.
Sure. Are you referring to pharmaceutical vendors themselves coming up with their own model?
Drug makers.
Yeah, drug makers. Agreed. But I also know of very specific situations where there are startups that are actually doing something on their own, right? I mean, there's nothing that prevents you from going out, taking pictures of labels, right? And then combining that with, a large language model of some kind, right? And then offering that as a service.
True. Yeah, absolutely. Okay.
So again, we've been talking a lot about natural language and text to text, but note that there are other Gen AI large language models. There's DALL-E, text to image, Sora, text to video, MuseNet, text to music, and of course Codex used with GitHub in terms of code generation. It's also used within Copilot. So
It's fantastic.
yeah, no, it is quite good. Although I am starting to read some interesting, I guess, feedback on that as it relates to code bloat.
Yeah,
Because so this is back to the human in the middle challenge, right? And that is that, what we're finding, and again, it's kind of a trend, is it's so easy to generate code by the developers, the programmers, right? That they just kind of take the code and copy and paste it. So rather than taking it and refactoring, does anyone know what refactoring is? Kind of like redesigning, your object model or, whatever to make it more efficient or add more functionality. They're kind of like tacking on, right? And so, what's happening is that there's this kind of code bloat effect that's going on, which is actually resulting in kind of less efficient code that's kind of being I'd say added to kind of overall code base, if you kind of think of it that way. There's also this idea of what's called model collapse. Anyone heard about model collapse? So think of the echo chamber idea, right? So if you've got, this kind of goes back to the question here at the end, the idea of just sort of like, models just talking to themselves kind of thing, in an echo chamber kind of idea. So if more and more information or content that gets kind of added to the corpus becomes generated as opposed to legitimately human created, what can happen is the AI models begin to collapse because what they need like original new content in order to be effective, to continue to be trained. And if
Humans writing stuff.
humans actually doing stuff, being humans, right?
Yeah.
As just letting the machines do the work, right? What will happen is the models will degrade and the results will become unpredictable, if that makes sense. Kind of a dilution effect. Okay.
Well, and all that code base generation, for us, it's really just building your starting point. Right? You still have
Well, it should
human in
be.
the middle
It
is
should be.
never going to go,
It should be. It
at
should
least
be. Yeah.
in the near future, go away from coding.
Yeah. No, I agree with you. Okay. I'm going to need to speed up here a little bit. So, okay. So what's a GPT? There's a little bit of a kind of confusion between, well, what's the difference between a GPT and an LLM? Because they kind of seem to be kind of commingled here. And I think really the idea here is that the GPT typically is a subset of LLMs known for their their natural language ability, and it's most predominantly encapsulated in a chat GPT kind of idea, right? That's why we just call them GPTs, right? Because we're kind of, it's back to the kind of generic, Kleenex to mean tissue kind of thing, right? So we're just saying, well, GPTs are like large language models because they kind of go together and it's with a chat interface and that kind of thing, right? So when we talk about GPTs, they're kind of very closely related to a large language model, although I would say that there's probably a little bit more of an emphasis on that chatbotting kind of interface. Okay. All right, so there are limitations to large language models. Surprise, surprise, right? So the large language models, they can struggle with nuance here and understanding the context. And so the way that large language models can be nudged, if you will, around nuancing is to be explicit in your prompts. Because it doesn't know what you're thinking, right? You may know what you're thinking when you're typing in the prompt, but it doesn't really know, which is why you need to be much more specific to sort of deal with that nuance, right? The other thing to note is that, this may sound weird, the large language model doesn't know really what you're asking it, and it doesn't really know what it's sending, if that makes sense. Okay, so it's just a big pattern matching algorithm. So we're all familiar with type ahead, right? The idea, on my phone or something like that, I start typing something and it like guesses what the next word's going to be. Okay, so imagine on steroids. That's kind of what's happening with a large language model. It's not just guessing what the next word or words might be to kind of complete the sentence. It's generating the whole thing. It's generating like the whole document, right? And it's doing that based again on patterns that it's seen based on the data that it's been trained. So it doesn't really know when it says, George Washington was the first president of the United States. It doesn't know what that really means. Does everybody know what I mean by that? It's just simply spitting a pattern back out based on what it thinks it is, based on what it's been trained to do, right? So that's why it's called artificial intelligence, because there's really no intelligence. I mean, there's intelligence in the algorithm and there's intelligence, but this is all human, right? There's intelligence in the choice of the data that was used to train the large language model. With the large language model itself, it doesn't know. It's just responding. And we talked about the quality of the input data, affecting the output. All right, small language models. Again, we talked a little bit about this already, but the idea with SLMs is that they're fine-tuned for specific domains or tasks, right? And the SLMs can actually be more beneficial because their use cases are narrower. Again, the applications are narrower, right? And so the quality of the results are going to be better, maybe more specific, more detailed than what you might get out of a large language model interaction. Okay. The other thing here is that their smaller sizes can make them more suitable for either an on-prem deployment versus the cloud, right? Because you have the ability to store that large language model locally, let's say, right? Or on a mobile device. So it's just more portable, just gives you more options. I would see this as a watch this space, small language models. I think there's just going to be a plethora of both licensable as well as within industry and corporations, them beginning to build small language models. Okay. Now, when we look at GPT-4 or OpenAI or Llama or any of the other large language models that we saw on the previous screen, those are defined or called foundational models. Okay, they're foundational models, meaning the idea here is that you're using that as the basis, and then through prompting and through contextual data, to your point, right? You're going to be refining that, but you got to have something to build on top of with your prompt, right? So that's really what the large language model or the small language model is designed to be, is that foundational model. Okay. Now, again, note that when it comes to customizing a foundational model, right, this is probably not what you're going to be doing in your organizations, right? This is what these deep-pocketed ISVs are going to be doing with their models, okay? Why? Well, because, again, it takes lots and lots of data, right? So let's say Llama, let's say Facebook, they want to come up with the next gen large language model, right? Well, they're going to have teams and teams and teams of people program that thing, and they're going to be, again, firing it with lots and lots and lots of data, and it's going to take a lot of money and time to do that, right? But they're going to turn around and they're going to monetize that, right? They're going to monetize it through licensing or whatever to the rest of us, okay? So this will tend to be a more ISV-based approach. Now, there may be some organizations that have some very deep pockets that decide they want to do this, right?
ISV.
Independent software vendor, like a Microsoft or an Apple or Amazon. Amazon's even in this business, right? So, all right. The other way, though, you can customize a foundational large language model is to your point, and that is adding or providing it additional context. All right. So you do that either through your prompt, refining your prompt, refining the prompt interaction to narrow it down to what it is that you're trying to get, or you're providing in-context learning through RAG. What's RAG? Retrieval Augmented Generation. All that really means in a nutshell is that you're providing additional context, if you will, on top of the foundational large language model in conjunction with the prompt. That's the three legs of the stool that I talked about. Okay. So those of you that use ChatGPT, how do you do that? Oh, well, you are chatting, but how do you add the context?
So I approach it like storytelling, right? Like I assume I'm asking Kurt for his input on a topic that he's never heard before, right? So I want a specific opinion from Kurt, so I'm going to give him all the relevant information, right? That isn't broadly available.
Sure.
And I look at it like, you know, drafting a story almost and pump it
Okay,
in.
okay.
And then refining from there, asking
Okay,
questions.
So there are a couple ways. I could take large text blocks, copy and paste them in the chat, and use order indicators to tell the prompt. I could have a huge prompt, right? The prompt itself actually contains the data in the prompt, right? And the prompt, at the end of the day, however you do it in the interface, you may say, hey, I'm going to upload some files in ChatGPT and have it use those files as context. At the end of the day, when it creates the prompt and sends it off to the large language model, it renders it all down to some huge instruction set. You just don't know that, right? Behind the scenes. Those UX elements, and we'll see that with Copilot, are supposed to make it easier for you to interact with the large language model, right? But at the end of the day, it's just a huge prompt. Okay. It's just handling that for you behind the scenes. Okay. All right. So grounding. So the idea of grounding is to take your either outgoing prompt or the results coming back, and you're grounding it, or you're kind of comparing it, or you're bumping it against something to refine the validity of either the prompt going in or the results coming out. Okay. So it could be used to reduce the hallucination effect, the idea of kind of checking the accuracy of a prompt response. Okay. And I'll just jump to the last one again, the retrieval augmented generation. Again, what you're doing is you're using the grounding step with that contextual element with the content to help refine your results. Now we'll see when we get to Copilot that Copilot adds an additional step, Microsoft Copilot with Microsoft 365, and that is it grounds through what's called the graph. The graph is a combination of users, okay, operations, and content. It's all of your emails and your chats and all that kind of stuff. But the graph knows what your permission sets are too, right? Your role-based access controls. And so through grounding, Copilot can ensure that the results coming back, okay, are filtered based on your permission set. So you only see the data that you're, available to see. LLMs can be extended, again, depending on the LLM or GPT model that you use. We see this again specifically with Microsoft and with Copilot, in that the LLM can be extended through graph connectors, as well as plugins. So this is a way, for example, that you can add that RAG element, the retrieval augmented generation, that may not be file or content specific, like the Word documents out there, right? But it may be information that I have in Fabric, for example, and I'm using that information as a RAG element, all right, in order to set the context for my prompt interaction. All right, so we're going to turn the corner here quickly and talk about prompt engineering. Again, the idea is that you're asking a question, or you're telling the large language model you want to perform some kind of an operation. Subtleties of prompts. You can see here the idea is that if you give it a really generic prompt, you're going to get very, very generic results, which may or may not be what you're looking for. But the more information that you give it, in this case, you're really telling it to summarize your results in 3 sentences, right? You're giving it some idea of what you want the output of the format to look like, right? So the more information that you can give the prompt going in, the better the results are that you're going to get back. So some things to consider here with prompting is you want to provide as much context as possible. You want to try to take and break down complex tasks within your prompt. So that probably means your prompt is not going to be 1 sentence long. Because you're generally speaking, you're wanting it to do something relatively complex, right? So it may be a paragraph or a couple of paragraphs in terms of your prompt, right? Now, how many people want to do that? Do I see the trough of disillusionment looming ahead? Right?
I want an AI that
Yeah.
will generate a prompt to give to the other.
You know what, this I think is gonna be, this is watch this space, right? What you're gonna see is more and more work being done on trying to reduce the prompt difficulty, right? But where we're at today, in order to generate good results, you have to be able to write a good prompt. That's just where we're at right now, okay? You can provide examples. This is called shock prompting. I don't know if you guys are familiar with this, but you can basically give it some examples and tell it kind of what you're looking for in your prompt, right? Cues, same kind of idea. Use formatting to mitigate recency bias. Does anyone know what recency bias is? Okay, so the idea is that strangely, the large language model is always promote the last things that you said in the prompt over the first things that you said in the prompt. So sometimes you got to repeat yourself. So what you said in the beginning, you need to say at the end again to remove what's called the recency bias. Right?
You call it shock.
Well, shock prompting is giving examples. Right? That's kind of like cueing. I use chain of thought all the time. Does anyone use chain of thought? Okay, so we talk about hallucination. It's like, hey, how did you come up with your results? So I use the chain of thought phrasing a lot because by that, what happens is it returns information on how it found the rationale about how it found its results. Okay, I'll also say things like citations or something like that. Right? You can do those things. That is the human in the middle, making sure that you're doing some kind of auditing on the results coming back, okay? So some best practices here. You want to start with the end in mind. So what is your goal in the prompt, right? Next is you want to set the stage. Why do you need the information? What are you going to do with it? Giving it that kind of frame of reference. Define any constraints or parameters. In other words, where do you want, let's say, the source data to come from specifically? And then finally, what is your expectation on the output format? Do you want it in a tabular format? Do you want it summarized? Okay. So kind of breaking it down, right? What we've got is we've got an example going on here. So if we look at a prompt construction, what we're doing here is we're saying, okay, I want to start with the end in mind. I'm going to generate 3 to 5 bullets. So I'm telling it kind of what I want that output to look like. And then next I'm setting the stage. Why am I asking the question? Well, because I want to prepare for a meeting to discuss their phase 3 brand campaign. Well, that's material information because, you know, what it's going to do is it's going to key in on that request in the prompt to find information that's specific to that. And then like source-wise, focus on email and Teams chats since June. Okay, so I'm telling it a time frame, and I'm telling it what kind of data it should consult. And then lastly, I'm saying just use simple language so I can get up to speed quickly. So this is just kind of part of the delivery. All right. Well, okay, there's a paragraph. There could be 3 or 4 paragraphs. Go. Okay. But again, the more information I give it, the higher quality of the result's going to be. We are about at time, 10 o'clock. So I can keep going. The rest of the presentation is going to be focused really a bit more on Copilot specifically, which is Microsoft's family of Office tools that work with generative AI. I think up till now, what I've tried to do is make the presentation a bit more kind of generic in nature. So I'll keep going. I probably have maybe another 15, 20 minutes, or what would you like to do?
Somebody online, Woody, had a question.
Okay.
There, Kurt.
Yeah.
Starts with,
Is there an amount of data that seems a good size to start teaching an algorithm? Think about years of data or items in fields to be analyzed. So I'm assuming the question is about training a large language model. Okay.
It's actually about training small language models.
Oh, small language? Okay. Typically hundreds of millions of parameters for a small language model versus hundreds of billions.
I saw that in your presentation, and I was a little, but when you spoke to the pharmaceutical company that might be developing their own small language model, it's hard to think that they've got hundreds of millions of lines of data. So if you do one that's so specific, is that possible, or is that a waste of time?
So your specificity, again, will be gathered with the three legs of the stool, right? It's the prompting, it's the larger small language model, and it's the augmented data that you use, right? So the question is, where do you want to spend your time or your effort? Okay, you can spend your time or effort on the model, whether it's a small or large language model, which is again is foundational. Okay, they're the three parts. Okay, so you want to spend your time on the foundation. Okay, these aren't mutually exclusive. Do you want to spend your time on the augmentation, the content that you're adding context, right? Or do you want to spend your time on the prompt? Okay, now, again, I'll just say hypothetically, a lot of it is, well, what is your intent? If you're an ISV, an independent software vendor, or maybe a pharmaceutical vendor, you're like, well, you know what? I want to spend my time on building a small language model because my interest is in monetizing that, licensing it, monetizing it, right? All right. If on the other hand, you're talking about an internal corporate use of AI, they may be like, hey, you know what? We don't have time and money to spend on either training a large or a small language model. Okay, so our bet is going to be on content and RAG. That's where we're going to spend our time and on better prompting. So you really have to look at kind of all three together and then figure out where you want to make your investments.
I was gonna make a comment. I'm not an expert, but I was looking at a person who posed the question, can AI write a Bach fugue? And if you search for that on the web and find some of the examples, you'll see how they broke down Bach's music into a language that fed a model. And then they started to break down how Bach composed fugues. And you'll see how they created an enormous prompt in my mind. And in the end, came out with a result that they fed back into a MIDI computer sequencer that actually played the result. But it was very instructive about like how to build a small language model, how to break down your data, pose the question, figure out what you're trying to get as a result, in not exactly in the field where we work probably, but something we can all relate to. So
yeah, no, thank you for that. So and there's this kind of black box element, right? I mean, we all want this stuff to be very, very easy to use and with little or no effort produce the results that we want, right?
of course,
We want to have it all. I guess the point, and thank you for the comment, is that there's a lot of work that goes on both in building this thing as well as perhaps hiding that prompt that you talked about, hiding that from your user interface or your user experience, right? I mean, even if you're just are putting a couple of sentences out in the prompt, chances are you're generating something quite large and lengthy, right, on the back side that you just don't even see, right?
Yeah.
Now, the more rudimentary the GPT is that you use, okay, the more into the intricacies of the prompt you have to be, right? However, the more control you're probably going to have as well if you get pretty good at it. Kind of going back to somebody talked about SQL or something, right? It's, you're not writing SQL, but you are, using natural language as a way of kind of really telling it what you want. But yeah, so I think again, if I were to predict where things are going to be going in the next year or two, right? I think it's going to be faster and more specialized models on the one side, right? the more use of retrieval augmented generation in a very kind of user-friendly way, trying to tell it what additional files of content you want to point to, and then hiding the prompting or making the prompting more more refined and more productive, but you not having to worry about how to write it.
Right.
See, so the question is, how is all that going to look?
And there is a Bach GPT
Mhm. Yeah.
model out there. So
Because that trough of disillusionment, I think, is around the corner here, and I think organizations are going to be scrambling from an adoption perspective, trying to get all of us to adopt it, right? Well, if there's resistance in adoption amongst corporate users because it's just too hard to get the results through the prompting, well, Microsoft, believe me, they're going to do something about it. It's just going to take some time. That's all. So, what would you like to do? You want to close it down now, or
We just had the survey.
okay?
I'll post
All
that
right.
right now.
Great. What questions do y'all have? This was meant to be 100 level, introductory stuff. A lot of you may already know this stuff, but I appreciate you attending, and would just love to get your feedback and what other questions you may have.
I got a question for you, Kurt.
Yeah.
Great presentation, by the way.
Thank you.
So if you were gonna, push more like self-help or IT support for, internal associates, would you hook up to a large language model and then do RAG on domain specific of that company's like knowledge articles, or would you, because you probably wouldn't have enough content to do 100 million.
Yeah, absolutely.
Right.
Yeah, that's the way I would propose. Yeah, so you're either using a repository of tickets, or you might have a database. In the case of using let's say a plugin or graph connector, and again, this is the context of Microsoft, but some way of feeding or integrating the foundational model with the RAG, however that works. It's either serving up files or a repository, making that available to the large language model and the prompting, right? Or it's allowing it to get to one or more data sources of some kind.
Could you get the benefits of the RAG or can you get the benefits of the small language model, where it's higher, faster processing? With a RAG that's still connected to an LLM, because most of the content probably coming back from the
Sure.
prompt
Yeah.
is from the RAG rather than the large language model.
Well, actually, in that particular situation, if you're using a small language model, what I would see is the RAG is augmenting the small language model, not the large language model. So in that case, you're probably, I guess there are situations where you could try to combine a large language and a small language model, but I would expect if the large language model, again, the benefits are the speed and the narrowness and depth, if you will, of the information, right? If you could augment that with RAG, that's even more specific. Wow, you'd get a really, really refined result, I would think, with not a lot of prompting, probably.
Right.
Yeah. Yes.
You mentioned this is like a 100 level overview of the presentation.
Yeah.
Do you have suggestions for the 200 and 300 level? Are there other classes, other user groups, other places to go?
Let's see. So where I would go probably with a 200 level would be to dig into the prompting and the RAG elements. I mean, you could probably talk a little bit more about large and small language models. I think, hey, let's build a small language model is probably like a level 400 or something. I mean, that's kind of like way out here.
Mhm.
And we're really getting into Python and this kind of stuff, right? This is like for developers.
Yeah.
Right. But I would say for this kind of group, the next step would probably be getting more in depth into the prompting and the result setting and the RAG. Hey, how do you effectively set up RAG, right? A retrieval augmented generation, right? How do you do that, right?
Mhm.
I would say it's probably 200 level.
You think that's just personal research, or are there places in town that, again, I don't know if there are any other monthly user groups or anything like that, if anybody else does.
Well, AI, at least at this point in time, tends to be either fairly 100 level or introductory, or it's like on the other extreme. Hey, we're going to build a large language model using Python or something like that, which is really like a dev kind of thing. I'm not seeing a lot in that middle space, which is taking folks like us to the next level with, say, prompting and that kind of thing. Right? So I would say that, and again, I'm not aware, to answer your question, I'm not aware of anything that's necessarily kind of focused on that. I actually have seen some classes offered online specifically on prompt engineering.
Yeah.
Okay, so if you're interested in kind of some self-directed training or study or whatever, you may look to something like that. Could there be, some user group, meetings that are on that topic? Yeah, perhaps. Again, we have this meetup group, which is AI content collaboration. And, some of these kind of discussions can be had that way. But again, if there's interest in this group, we'd love to get that kind of feedback to know if there's a need. You say, hey, you know what, this would be a really good topic or set of topics to cover. We could help with that from a user group level.
I was actually even thinking about doing it if it didn't exist.
Oh,
So I will tell you
perfect.
that I'm interested.
Well, perfect, awesome. We'll jump on ship here.
Can you fill out the survey so I know that? I can follow up.
Yeah.
Are you familiar with any models that would do something besides text for prompting? Like, is it like, for example, let's say we want to say, I'd like take these 3 pictures, use the pictures as the prompt rather than paragraph of text.
Yeah, a lot of them can do that.
Yeah.
Now, yeah, you can take a picture of
Which one?
something and it'll analyze the photo pretty
Oh,
good. pretty
which one?
Right.
A lot of them.
A lot of
Yeah.
Yeah.
But ChatGPT Plus is one example. But yeah, U.com, Perplexity Pro, there's a variety that will.
Yeah, I would say though that, I guess the question would be, so without some kind of natural language interface, right? The best you could do is train it to generate something that you want by just simply feeding it images. That could be long and arduous. Do you kind of know what I'm saying? If all you could do is set it examples, but you can't really like guide it through language, I mean, what do you do outside of just sending it more images? You know what I'm saying? So while there is the ability to combine this is kind of like shot prompting, right? It's like, hey, this is an example of what I'm looking for, right? So use this as the model, but it seems to me you're still always going to need some natural language way of guiding it.
And just to clarify on the few shot, when you talk about examples, this could also be like uploading PDFs to Claude and things like that,
Yeah,
right? Okay.
yeah, exactly.
Yeah.
Although one could argue that could be RAG as well, retrieval augmented generation, because you're essentially adding context through additional content.
Great presentation, by the way.
Oh, yeah.
Like this is such a newly breaking technology. You never quite know.
I always struggle with how much I assume the audience knows, versus what would, I mean, obviously we want this to be of value to you all, right? I mean, thank you for spending an hour or two on a Friday, to come and attend. We want it to be worth your while. So please give us feedback.
And just one quick question on the, and I know it's like a whole other side of this, but when you talk about an organization that would use maybe a localized model, maybe they're concerned about privacy and that sort of thing, like just from the options of like what kind of compute or infrastructure to process these requests and bounce it off, local databases and that kind of training. It's just an interesting.
Everybody's in the monetization game, let me put it that way, right?
Yeah.
And so there are SaaSes that you could subscribe to that actually will sell you compute power to build a small language model. So everybody's getting in the game, right? I mean, so there's always going to be a way to do it. The question is, how much money do you have? So I think, gone are the days where you're like scratching your head going, well, gee, all I really got is my server under my desk. And, how am I going to do that? That's the 50s, right? Those days are gone. Everything is kind of rentable and monetizable, right? So it's really just finding the right vendor and offering.
Yeah.
It's moving so quickly. So yeah, the ability will always be there, or it will be there quickly. It's just how much money do you want to pay?
Yeah, and that's because I'm thinking about from like a. How do you get low latency, lower total cost of ownership, to be able to use some things like this? And it's interesting because we're in the phase of like, when we talk about low latency, it's because humans want that, immediate feedback. And like, man, we're not even talking about agentic flows at that. I mean, what's the latency then when now there's agents out there doing things?
Yeah.
It's fascinating.
Well,
right now.
we are seeing, we see, 3 and then 4 and then 4 turbo and V next and V next and V next, right? It's always about getting faster and getting better results, faster and better, faster and better, faster and better, right? And so that you've got that going on too, just with the large language models themselves,